Hello everyone, and welcome back to our series of tutorial about OTBIOLAB software. For all the people who don't know me, my name is Fabio, one of the software developer of the company, and today I want to show you one of the main and probably the most important tool of all the software, which is the decomposition tool. So let's move and open one file. I've prepared a tutorial file, which is a file that contains a trapezoidal feedback for the force and obviously EMG acquisition of a tibialis muscle. So now how we can open the decomposition tool? First of all, you have to select the track that you are interested in, the native processing, EMG, decomposition. This will open what we have called the launcher. This is the decomposition launcher. You can select the track, unselect it. This is not too much important here in my case because I have just one track, but you can select more track and open the decomposition tool with more button here that you can select, unselect, and so on to run the decomposition algorithm in a faster way. Then here you have the parameter section. For all the people who already used our instrument, these are exactly the same parameters of the previous software and probably of the standard algorithm of the decomposition. My suggestion is try to click this button. This will open a quick user guide that will show you the function of all the parameters that we use inside the algorithm. Obviously, we can also provide with the entire paper, scientific paper about the algorithm. You can find it in our material inside our website. And then there is this toggle button here, which can move from precise to fast. This simply change a little bit the conversion criteria of the algorithm. So in this way you will obtain more precise result, but in a very slow way. With the fast you will obtain good result, but in a faster way. So my suggestion is, if you are doing a protocol and you want to see in a fast way if there are some motor units inside the signal, use the fast mode, just as a fast check to see if the signals can be good for the decomposition. And then in a second model, you can open back in a second moment, you can open back the same file, change it in precise, and run again and see how the results change. Then there is some pre-processing that you can do, for example, some simple filter to remove noise interference. And then there are also some run modes that I will show you in a moment. Here, if you want to add a force track, here remember that in the main we have our force signal. You can simply click in this button here. Here you will find a list of all the auxiliary channels that can be inserted in this space. Now we have just one, so click it, select, and now we can simply run the algorithm. Now let's go back to the run on track selection, to the run possibilities. One is the run on track selection. What does it mean? That if you click run here, the algorithm will use the selection that you have inside the main tab. So here I've selected, for example, all the track. Now with this toggle here and click run, you will execute all the algorithm in all the track. If I do something like this, I will run the algorithm just in this selection. If you change it, here you can write directly your interval. Obviously, if you have more tracks here, the same interval will be used in this mode here. In the previous one, it will be executed just in the selection that we have inside each track. So if you have additional track, each one with its own selection, it will be executed just in that. Now let's go back for a second here. For all the previous users, the people remembered that there was a restriction, a constraint in the time interval. Our algorithm could be executed just in a time window between 20 and 100 seconds. Now we have removed the type of constraint. Now, for example, we can choose between 0 and 10. If you click run, you will see this error message. It's not an error message, a warning message that it's just saying to you, pay attention, you are running the algorithm in a time window, which is not usual. Are you sure or not? For now, this was just for showing you that you can run the algorithm in all the situations that you want. But now let's go back to our classic one. So run on track selection, going back to main, select everything, going back to the composition, click the fast mode and click run. This is our run window. Here there is a stop button if you have done some mistake, and here there are some information. Pay attention that the algorithm is working well if you can see a lot of done okay. If you have too many done not okay, it could mean that probably the signals are not good enough, or maybe there is something wrong in the subject preparation, but this can be a quite good feedback to understand if the algorithm is working good or not. Okay, at the end of the algorithm, this will be the page that should be visualized. So let's start from the higher part. Here you have a list of all the motor units extracted in this step. I say in this way because you can go back to launcher and run it back again, for example, by changing some parameters and so on. So the launcher is already here. You have not to go back in main and click the decomposition button. You can simply go in here, change what you want and run it again. Here in the motor unit list, obviously you can change the motor unit by clicking on it, and you can visualize the result. Here now, I will be here in a moment. Here there are some parameters that you can see: the seal, the silhouette, the covariance, and the peaks that can give you some indicators about the good quality of the result and of the motor units that you are analyzing. Here there is the toggle button here that can sign the motor unit as accepted or rejected. There are also some shortcuts with an accept all button, a refuse all button, so you can simply do something like that. And for all the people who are quite used in doing editing of motor unit, probably for all of them, they will know the MAUEdit software, which is an open source software, which is highly used to doing some editing of motor units. So with this button here, you will be able to export the results obtained by our algorithm and editing these results in the MAUEdit software. For show all smoothed button, I want to wait for a second before telling you what it does. Now, let's going back to the results. So here we have 3 tabs that show you the discharge rate. Obviously we have our force track because we have selected it. Then there is the firing rate, and then there is the grid. The grid gives you an idea of the shape of the motor unit. You can change the orientation. It will be obviously aligned with the muscle fiber of the muscle that you are analyzing. So here you can see how we can see propagation, for example. We can change the plot time from 50 milliseconds to 100 milliseconds. We can change the mode. So now we are visualizing differential motor unit, but we can also visualize monopolar motor unit. Now, let's see firing rate and discharge rate. The firing rate and discharge rate are the graphs that are mostly used to doing editing. So normally we select them in this way, we use them in this way, and so you can compare the firing rate and the discharge rate. And now I want to explain you one of the main features that we added in the new decomposition tool, which is the possibility to do some editing of the motor unit. So for the editing here, we have a list of commands that gives you the possibility to interact easily and in a fast way with the plot. So as first thing, I want to hide for a second my force track. Then, for example, let's see one functionality, which is the left mouse click. If I click the left mouse button, I can move my graphic. And you can also see how the discharge rate and firing rate are synchronized along the x-axis. You can also do the same thing in the discharge rate. There is also the zoom functionality, which you can do it with the mouse wheel to move inside the graph or outside of it. And there is also the drag functionality, the drag zoom that can be done with the right mouse click. So if you move in a horizontal way, you will zoom in the x-axis. If you move in the vertical way, you will zoom in the y-axis. And obviously the same thing can be done can be doing this thing here. Now there are also two additional buttons, which is the control and the shift. The control can be used together with all the commands that you already see together, but it will work just on x-axis. With the shift, all the command will work just on y-axis. So for example, let's click Control and then click left mouse click. You will be able to move just on horizontal axis. If I click the shift, I will be able just to move here. Obviously the same can be done here. You see, the same for the drag. So control and here, and the same for the zoom. So control will zoom just on x-axis, shift and mouse wheel, it will zoom just on y-axis. Now with just a simple mouse wheel click, you will do the auto scale. Now, yes, the last functionality. With the mouse wheel pressing and drag, you will be able to zoom in the red zone. So you can do something like this. The same, obviously, for this, which is just limited on the vertical axis. And now let's move in the editing. So I showed you this command because these are highly used in doing editing. So now let's zoom in a x-axis. So control and zoom. For example, let's suppose that this point here of the firing rate is not correct. So here we have two additional buttons, the D and the A. D will delete the point which are selected. So now you can simply drag and that point will be deleted, and voila, you can see the difference between firing rate and discharge rate. The same if you want to remove, for example, more button here, you will see this kind of results. Now if we want to add them back, we can simply do something like here. And that's it. So this is the editing of the motor unit. You can do whatever you want. You can do add, delete, and so on. And that's it. Now, the last thing that I want to show you are the export functionality. What we mean for export functionality? We mean the possibility to move the source, which is the blue signal here, the firing rate, which is the signal here, in our main tab, or also the motor unit. So now this button here can have a sense for us. So let's suppose that I want, for example, to export in the main just one motor unit. So I can refuse it, just select, for example, motor unit 3, and here I can click the button export accepted motor units. Now go back in the main, and here I can find my motor unit. Now let's go. Obviously, if I select, for example, 3 of them, I can run export accepted motor units. We go back, and here we can find the 3 motor unit exported. And here you can also say, okay, I want to export the source of the motor units that are accepted. So for example, I can do like this. I go back, and here I'm able to find my source. The same for firing rate. And here I'm able to have my firing rate. We can also do the export function in a single way. So for example, of this one, I want to export the source of this specific motor unit that I'm working on. So I can click export source, and here I will be able to obtain that source, the firing rate, and here I'm able to find the firing rate. The same for the discharge rate. We can also have here an export function, and here you will find our discharge rate exported. There is a button that I didn't explain you, which is the show hide smoothed. If you click it, this is a sort of average, a windowed average of the point of the discharge rate, which enables to show you this kind of signal. And here it takes also a functionality, also the show all smoothed. The show all smoothed will show you all the motor unit the discharge rate of all the motor unit in a smoothed way. So if you click here, you will obtain this kind of graph, which have all the same functionalities that we saw together. So this way, this way, this way, and so on. And that's it. So thank you guys to have followed until here. I hope this tutorial will be helpful for all of you, and thank you to have was here with me. And bye, and have a nice day. Bye to everyone.